So how about JB? Let's go for KA first, okay? KA. Let's go for KA. It's the same input set I, A, B. So I can be 0 or 1. This can be 0, 0, 0, 1, 1, 1, 1, 0. Okay. So I'm copying. I'm looking at this one. Sorry, I cannot show both of the places at once. But I will copying from here. I will be copying from here to this table according to the order, right? So check whether it's correct. This is for KA, right? KA. So first is don't care, or 0, 1 is don't care, then 2 is 1, 3 is 1, 4 is don't care, 5 is don't care, 6 is 0, 7 is 0. Okay. Now what is the group here? What is the group here? As you can see, again there are 4 x's, we don't care, and these two are the signals we must include, right? So you can just ignore everything. I mean, you can just remove all those things and take this group, right? This one and this one only. But in that case we will have to include two variables, right? So I bar is there, then we need a, right? B, don't mind. But in that case we will have two variables in our, or two variables in our circuit. But we don't need to do that. We can reduce it into one, because we don't care this one. So why not include them and build a for group instead, right? That's the logic. So we can get this one and it will be a for group. Then we don't care about I as well, right? Sorry, we don't care about A as well. We only need to be I bar, right? This I bar is the entire signal needed, right? So I have K equals I bar O I dash. Okay. As far as these two are included, we don't mind what happened here. So we can include it to simplify our circuit. Now the alternative would be I bar dot A, right? Because this is the A group, right? This is the A group, I bar A. But here we need another AND gate, right? Why do that if we can just uh, get away with only, sorry, can't see. Anyway, if we can just get away with I, why to put the why use I bar A, right? So we don't need that. We can just use I bar. Okay. So let's go to next one quickly. Next one is JB, right? JB again. So I go with I A B 0 1 0 0 0 1 1 1 1 0. Okay. So I'll be copying the signal from JB here, right? JB, this column. Okay. Okay. So let me copy it. 0 x 0 x. Don't I mean, I hope you know the order, right? Because this is the let me write the order also if somebody is not familiar with. Now 0 1 2 3, right? There's a swap because 1 1 is here, 1 0 is here, right? 1 2 3 4 5 6, again another gap here, then 7 is here, right? As you can see, 1 1 1 makes 7, right? So there is a swap of order. So if you are not familiar, please practice that a little bit more. Anyway, so let's copy the other half also. 0x 0x 1x 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 1x. Okay. So now what is the group? Again I will be using this don't care conditions to simplify my circuit, and I will just take this entire group rather than these two, right? If I wrap around and take one of I mean, you can take only these two ones only, but this is simpler, right? Then you can go with now our signal is JB, right? JB is just I. Okay, there's nothing to complete it with. Okay, so that's very simple, right? This one we don't care about the don't care conditions. Then the last one is KB. So I will go again as I AB 0 0 0 1 1 1 1 0. I is 0 or 1. Okay, so I'm copying from KB here, right? KB signal here. This column I will be copying to this uh, K map. Okay, x1 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 x0. Am I correct? So check with your work as well whether I'm doing it correct. Okay, then what are the groups? Now you need to take a look carefully here, right? So here also the same principle applies. You need to find either 8 group is the best, right? Then the output will be just 1, but we don't have 8 group because here we have 1 0, right? So we cannot include that, we have to avoid that somehow. Then we are looking for 4 groups, right? So I mean you can just take two groups here, but it will be too complicated. That's why we are trying to simplify it by selecting 4 groups, right? Now this 1 is here, so I will just wrap this one entirely. So there is one group, or 4 group. Okay, then another group is something like this. Okay, does that make sense? Because now we have 4 groups which will be let's see what is the signal output. So what we did was here, it's KB signal, right? Cannot see. So this KB signal, okay, is now here it's A bar, right? This is the A bar group, right? Because this A is 0 both of the places, so we don't care about I, we only care whether we have A bar here. We don't care about B as well, right? So A bar or A dash O, right? Because there's another group now which is I bar. This is the I bar group, right? Okay, so now we have 4 signals, right? The first one is uh, JA, right? This one. Then we have JB is just I, this one, right? Then we have KA signal. Then we have KB signal. Okay, so there are 4 signals now. It's quite simple actually. Now what we can do is you can implement this one, and your circuit has now. I mean, circuit has 2 JK flip-flops. If we set the inputs of those J or excitation signals of those 2 JK flip-flops as these values, it will behave as this entire circuit or entire state transition diagram. So you can verify it using Xilinx or VHDL code and implement this in it and see whether it works, right? So I will show you the timing diagram and explain a bit how it actually implemented and work. But before that, there is another part given in the question. Propose a logic expression for the output signal, right? Now we have determined our state machine, and it's hopefully working fine. You can debug and see whether it works or not. But before that, actually, what is the output now? Let's reflect back what we did so far, right? Now we have a state transition diagram, and it's supposed to detect 3 ones in a row. That's the task, right? sorry. So if we have 3 ones in a row, which state we are in? Think a bit and reflect. So if we have only one input, one ones in our serial input, we will be at S0, right? If we don't have any, we will be at S0. One input, we are going to S1. Two inputs, we will be at S2. Three inputs as one, right? Essentially, I'm talking about ones here. So if we have 3 ones in a row, 1, 1, 1, then we will be at S3. Again one, four inputs, four ones in a row also. It's a kind of subset of three. 3 in a row, right? So that's not matter. We are still at S3, right? So if we need the output signal, essentially we can output the state of S3, right? So S3 is in our state assignment. We know that S3 is this one, right? 1, 1. You can refer to the table given. So S3 is determined as QA equals 1 and QB equals 1. Okay. So that is the S3 state. So if our flip-flop A is 1 and the flip-flop B is 1, then our output should be 1, because that means it's a 3 ones in a row, right? So we can just write output signal. Let's say it's F, okay. Pen is not perfect. Anyway, so F is just both of QA and QB should be 1, right? So it's QA, and so I just put this dot here, Q. Okay, so we have a output signal as well. So let's see the timing diagram of my implementation and how it works.